All right, good afternoon, everyone. Okay, so this period, we have a little bit longer than the other periods, but wanted to let you guys know that we're preparing for tomorrow's derivative pre-AP test. But because of our, we do only have 30, 35, well, in this class a little bit longer, about 40 minutes, for us to take our derivative portion of our test tomorrow, multiple choice. It'll be part 1. It'll be 8 questions, and it'll be over these topics. All right, and I picked problems that I thought would be representative of some of these topics that you see here. It's not comprehensive, so I encourage you guys to go through the other worksheets that we've done up to this time in preparation for tomorrow's multiple choice section. Okay. Okay, so I'll pick out a few problems for us to do, and but I'm not going to be able to get through this entire worksheet. So what I'm going to do is in the afternoon, 3:30 to 4:30, I'm going to go over the remainder of this worksheet 5. Now, it will be recorded, but that way, if you need some more support in the sense that the key is not sufficient, then you can join me on the help session, or you can check in with the video later. It'll be I'll put the link next to today's date on my website. Okay. Any questions about tomorrow before we start this worksheet? Okay. For those of you in the classroom, you guys also picked up worksheet number 6, and this is over integral topics. We're not going to be able to go through this at all tomorrow because tomorrow you guys will be taking your test. But I will have a help session over integral topics Wednesday afternoon from 3:30 to 4:30. So, but there is a correction that I'm going to ask you to make. If you're on Teams, I updated the document, so you should be good. But then I printed this out for the students in the classroom before I realized the mistake. So if you guys can just cross off number 2 and understand that there is an updated question and solution on number 2 on my website. So just circle it and just so when you do get around to working through the worksheet, oops, sorry. Okay, so worksheet, the integrals packets that you guys picked up. For number 2, this one didn't quite work out, so I put a similar one, but it's updated with the key, and yeah, it works out a little better. So yeah, so just circle number 2 and just understand that if you pick this up in the classroom, you can make that correction when you go through this worksheet. All right, so let's go to worksheet 5. Okay, let's pick off some problems here. Let's start with number 1. Okay, let's see. All right, so number 1, limit as x approaches c. C is a constant, but we also know that c is doesn't equal to 0. Let me zoom in a little bit more here. So first things first, we're going to evaluate the limit. substitute C in for all the x's. Oops, sorry, C squared. So we see that as we evaluate, we're going to get 0 over 0. And that tells us that the limit does exist. We just haven't found it yet. There's a hole in the graph. And what can we apply if we see 0 over 0 for limits? L'Hopital's rule. All right, so I encourage you guys to use L'Hopital's. I mean, there are times that you may be able to factor, but L'Hopital's just is more encompassing. It can handle a wide range of all these different problems. So let's make sure we know how to do L'Hopital's. So that means we can evaluate, find the derivative of the numerator and denominator. Remember, C is a constant. So when you find the derivative of C cubed, we don't do power rule. We don't make it 3C squared, right? We just make it go to 0. It's X that's a variable that we go through power rule for. Okay, so X cubed becomes 3X squared. C cubed becomes 0. X cubed becomes, oh, sorry, X squared becomes 2X minus 0. So just like with other limit problems, as soon as we apply L'Hopital's, we're going to reevaluate and see if that will give us a value that is other than 0 over 0. So C in for X. Three C squared over 2C. I can take out one of the C's, so I'm just left with 3C over 2. C doesn't equal to 0. It is a real number. All right, let's go to page 2. I'm just going to jump around to problems that I want us to look at. So let's look at number 4. Let f of x be equal to the definite integral from 0 to x of h of t, where h is the graph shown. Which of the following could be the graph of f? So we have to first understand that there's a relationship here between f and h, and that f and h are not at the same level. Okay. This tells us that h is really at a level below f because it takes the antiderivative of h to even move it up to the same level as f. So that tells us that h is really sitting at the derivative level of f because of that integral. So, but we can also do this. We can also take the derivative of both sides and then see that relationship a little bit more clearly. So I'm going to take the derivative of both sides. F becomes f prime. We know the derivative of the integral is just going to wipe out this notation. I'm just left with h with the x inserted. Okay, so we just have to understand that they call this the h graph, but really, because of this relationship, we're really going to think of this as f prime. This is the derivative graph of f. And so we have the derivative graph of f, and we're trying to figure out which of these could be the original f of x graph. Okay. So we have to just how to know how to maneuver back and forth, right? If I give you information about derivative, can you gather the graph about f? Or if I give you f of x, are you able to gather graph information about f prime? All right, so I'm going to label my f prime graph so I can have a little more clarity in terms of what I'm dealing with. Above the x-axis is positive slope. Below is negative slope. On the x-axis is slope 0. Okay, so what I'm going to do is I'm going to create a slope and concavity sign line, so I can just have as much detail as I can gather. I'll create my own. I'll create my sign lines. I'll create my own version of the graph, and then based off of, and then once I have my own version, I'll just have to match with the answer choice. Obviously, my graph is going to be different in the sense that the physical location will be different, but the hope is that the overall shape will be the same, and if the shape is the same, we can eliminate the wrong choices and arrive at the one that that has the shape demonstrated with these properties. So I'm going to move to f prime sign line. Now, f prime sign line, the points that I find that are significant for graphing will be the x-intercepts and also the peaks and valleys. And just so that we can kind of mark them a little bit more clearly, I'm just going to give these a name so I can just have some anchor points to target. So I'll call this B, I'll call this C, and I'll call this D, just so I can have some reference points here. Okay, so here's my f prime sign line. I know that for my slope sign lines, I'm targeting my x-intercepts, right? X-intercepts is going to be where the slope is 0, and then we can then gather positive and negative slope and draw our arrows within our sign line. Okay, so I'm going to say B and D. Okay, so between 0 and B, we see clearly above the x-axis, that's going to correspond with the positive slope. Between B and D, we clearly see these are values below the x-axis. And then to the right of D, positive slope. So just based off of the sign line, I can gather some information, right? I know that my original graph, there's going to be a relative max at x equals B. And we know that there's going to be a relative min at x equals D. Okay. I'll also create a second derivative sign line. And we know that if we're trying to gather concavity from the f prime graph, we're picking out the peaks and valleys, right? The peaks and valleys will be the points of inflection. So I'm going to say A and C are my points of inflection. And then we know the slope of the derivative graph is going to correspond with concave up or concave down. So positive slope is concave up, negative slope is concave down. Okay, so. Okay, between 0 and A, my graph is concave up, so I'm going to give it that, label it with that symbol. From A to C, my slope is negative, so negative slope of f prime is going to correspond with concave down. And then to the right of C, my f prime is rising, so therefore concave up. Okay, so we know there's points of inflections at A and C. I'm just going to create my version of the graph. I'm not going to look at my answer choices. I'm just going to base it off of. So for f prime, I know I'm targeting, here, I'll just go A, B, C, and D. I know that at B, I want a relative max, so I'm just going to target a point that is relatively high on my coordinate plane, so I can just have that target. I know I'm going to be doing a relative max. I know that at D, I want a relative minimum, so I'm just going to pick a point that is relatively low, just to make it obvious. And I'm not going to worry about concavity yet. I just want to get this shape going here, or get those properties going here. I don't really know what my curvature is yet, but I do know that my graph is going to have, it's going to have at least that that overall shape. Okay. Questions so far? So that's the big piece, right? we should be able to get the overall shape without having to deal with concavity. But now that we have a general path, we're going to go back and we're going to kind of give it a little bit more detail along the path. So we know A and C are going to be points of inflection. So let's give ourselves some target points. So wherever that graph is at A, just go ahead and mark it. Wherever the graph is at C, just go ahead and mark it. So that indicates that those are target points. That means that is where we want to target our concavity to change. So up until A, we want the graph to display concave up. So I know this is the path of the graph, but I'm going to force it into a curvature that that I would like to see. Concave up. From here, I'm going to force the concavity to change. So I'm going to give it that curvature downward from from A to C. And then from C forward, concave up. Okay, so if we now look at our answer choices here, A and B doesn't look anything like our graph. E doesn't look anything like our graph. So we're down to C and D. And C and D are very similar, but I think I realized that C is, I think, is the better choice. I think on my key I had D as the answer choice. I think the issue is here. This is the original graph. And there is, looks like that's a close to a vertical tangent line. So if that's a vertical tangent line, then the slope should technically not exist. There should be a breaking point here somewhere. So that vertical line makes it troublesome, even though everything kind of matches. But I think this is a better fit because we have concave up, concave down, concave up. We have a relative max and relative min in their right locations. So that's a little tricky because D and C look so similar, but I think that vertical tangent causes an issue. I think our answer choice is C. Okay, next one I want to look at is number 6.
Wait,
yes.
I thought that it would be D because the concavity changes at A, or because that's what I thought.
I think, yes, it does change at A, but I think this also changes at A, doesn't it? It's more apparent here. So I think the answer is C, but if I were grading this and you guys put D and you showed all this work, I probably would give you credit but I think the issue is that there's that vertical tangent, and that vertical tangent is slope undefined, and if it's slope undefined, it really should not show up on, it should be like a, yeah, it should be like a hole or, but yeah, this is kind of tricky because it's so similar, and just that one little technicality makes it a wrong answer. But yeah, ultimately, I probably, with all this work, I would probably give you credit for D, even though technically it should be C. Okay. All right, number 6. This is a calculator question here. Let f be the function given by x minus 4 quantity squared, and let g be the function given by e to the 3x. At what value of x do the graphs have tangent lines that are perpendicular? So there's two things that I notice here. Tangent lines. I know that tangent lines means we're dealing with slope. We're talking about slopes that are perpendicular. So we're going to have to work with the derivatives, right? So we know that we have to involve f prime and g prime somehow. So I know I got to make my way to finding f prime and g prime. So I think we've seen problems where it's asking, where it says, oh, the tangent lines are parallel. Then if that's the case, we just set f prime equal to g prime, right? We want to find a location where both of them share the same slope. So we set their derivatives equal. But here, it's asking where we want the slopes to be perpendicular to each other. So we're not going to set the derivatives equal to each other. We're going to have to involve perpendicular relationships. So what's that relationship for perpendicular lines?
Could we just do like f prime is equal to 1 over g prime?
Close.
Like the inverse?
You're close. But what's the relationship between slopes that are perpendicular?
They're opposite.
Okay. They're different signs and they're flipped, right?
Oh.
So you're close. Yeah. So that, but your idea is right. We are going to take that relationship and then force it into between f prime and g prime. So perpendicular means two lines have slopes that are opposite reciprocals. Okay. So instead of setting f prime equal to g prime, like you said, we're gonna try to do this. We're gonna set f prime equal to -1 over g prime. And once we get that settled, then we can do whatever algebraic steps we need to do to solve for x, and we may need our calculator to actually find that approximation for us. Okay, but first things first, we have to find f prime and g prime before we can arrive at this point. So f prime, we can go through power and chain rule. Outside's derivative times inside's derivative. G prime. E to the u becomes e to the u times u prime. All right, so now we're going to jump into this relationship here. F prime equals to -1 over g prime. All right, so I'm just going to distribute this through, and then maybe I can cross multiply here, see where that takes me. Actually, I'm not going to cross multiply. I'm just going to just add this over to the other side, right? So I have 2x minus 8. I'm just going to add that 1 over 3 to 3x over. I'm just going to have all the terms on the left side, and I can just get a 0 to show up. If I get a 0 to show up, I can just look for the x-intercept. This is not something that we can solve by hand. So here's what we're going to do. We're going to graph this function. And we're going to look for the x-intercept. Where is the graph going to cross the x-axis? That's going to be where our solution is. Okay, so let's. Two x minus 8 plus 1 over 3 e to the 3x. Okay. I think what I should have done was look at my answer choices and then chose my x values so that I'm just a little bit outside of either extremes. So let me go from -2 to 1. How's that? Whoops. Scale should be 1. All right, so there's my x-intercept. There's my solution. I'm going to do second trace 0. Choose a point to the left. Hit enter. Choose a point to the right. Hit enter. -1.143. There's my solution. Okay, any questions with number 6? Let's see. Let's skip to number 11. Let's do a mean valley theorem problem. So let's go to number 11. Does anybody still need to look at 6? Okay, so it says f of x equals sine of x over 2. There exists a number between pi over 2 and 3 pi over 2 that satisfies the conclusion of mean valley theorem. What could be the value of c? Okay, so let's set up mean valley theorem. You can also find it on your formula sheet. Is where the slope between the endpoints is going to exist somewhere along the curve. So we're trying to find the location on the curve where it matches exactly the slope between the endpoints. So endpoints are always provided for you. So let's go ahead and find the slope between the endpoints. So I'm going to find f of a, find f of pi over 2, find f of 3 pi over 2, find out what the slope is. Then I can fill this with the slope value, and I can find the derivative, and I can set them equal to each other, and I can solve for x. Now my f of x is sine of x over 2, but just so that we don't have to deal with a complex fraction, maybe you want to write it as sine of 1/2 x. That way, whatever x you have, because that's a fraction, you don't have to stare at a complex fraction. Maybe makes it a little bit easier to insert. So pi over 2, we'll go in for x. Sine of pi over 4. Sine of pi over 4 we know is root 2 over 2. Okay, insert 3 pi over 2 in for x. Sine 3 pi over 4 is in the second quadrant. It's also going to be root 2 over 2. So technically, this could have been what? It says mean value theorem, but technically this could also be, yeah, it could be Rolle's theorem. But just understand that Rolle's theorem is just kind of like a subset of mean value theorem. So it's still a mean value theorem. It's just that anytime our A and B, f of A and f of B are the same, we know that we're going to be targeting a slope 0. But yeah, that's what ends up being here. So if I subtract f of A minus f, or f of B minus f of A over B minus A, I'm going to get 0 because my y values are the same. Okay, so we know that the 2 points are directly across from each other. So whatever the graph looks like, we know the endpoints are exactly the same y value, which means that we can guarantee a slope 0 somewhere along the curve. So we're going to find f prime, and we're just simply setting f prime equal to the slope that exists between these endpoints. Okay, so here's f of x again. Okay, if I want to find f prime, go through a little bit of chain rule, or we can go through what we know with the sines rule, which is cosine of u times u prime. Once we have f prime, we're going to set f prime equal to the slope that exists, which is 0. So we set f prime equal to 0. Okay, it says what could be the value of c? Basically, we're trying to solve for x. I can divide the 1/2 over. So you can either kind of go through a little bit of guess and check, or you can go through and just solve this. But maybe guess and check is faster, right? Can you think of an x value that will cause cosine of this expression to be equal to 0?
Just pi.
Pi, yeah. So I think that is the answer choice that shows up, right? We know that cosine of pi over 2 is going to be 0. Okay. Now, if the answer is not as easy to spot by guessing and checking, we can also solve and go through inverse. So I'll show that step as well. If I want to solve for x over 2, I'm going to bring this cosine over, make it inverse cosine. And we can ask ourselves, well, what are all the values where cosine is equal to 0? Cosine is equal to 0 at pi over 2, 3 pi over 2. I'm just going to list out a couple in case we need to go there. And then if I want to solve for x, I just have to multiply everything through by 2. So there's more than one, right? So answer could be pi, it could be 3 pi, it could be 5 pi. It's going to keep going along that pattern, but then the only one that's available in our answer choice is x equals pi. Let's go to number 8. I did some derivative of inverse at a point yesterday from worksheet 4, but let's just, since we have time in class, let's just go through that. Here's number 8. Okay, let f of x equals x to the 5th plus x. Find the derivative of the inverse of f of x at x equals 2. So we know that it's always going to follow this pattern where if I want to find the derivative of inverse at a point, I'm always going to identify what I'm looking for, and then I'm just going to work my way around this chart. And by the time I circle all the way around, I'll then have, I would have gathered enough information to fill out what that value is. Okay, so the key thing here is that the top two, the first row is going to be information about the order pairs. And then the second row is going to give us information about the relationship of the slopes between the function and its inverse. So I know that the inverse, okay, so whatever that value is, I know that whatever that value is must be the y value of the original function. Oops, sorry, a. So I'm just trying to remind you some of the strategies here. The first thing you do is, just as soon as you know what the x value is, you can just put them all in these locations. And what's going to happen is now we can go to our function because the function is what's given to us, and we may have to work backwards. Okay, we'll take the y value, we insert it into y value, we work backwards, solve for x. Once we solve for x, then let's say it ends up being b, then we know that that must be the y value of my inverse. And once you have b, once you have that x value for the function, then you can find the derivative at that point. And then so you go through the derivative, you plug in, you get that slope, and whatever you find as a slope, that number is going to be showing up as the reciprocal on the inverse side of things. So that's the process. So let's do it for this problem here. I know I'm trying to find the derivative of inverse at 2. So I'll make my way around this chart here. I know x2 is the x value of my inverse, but we also know that 2 is the y value of my original. So we're going to take this 2 and we're going to insert it into the y value of my function. And I'm just going to see if I can figure out what the x value is. Bring everything over to one side, and you're going to see that this is not something that we can factor. I mean, we can go to our calculator, but this may be a non-calculator question on AP exam. And if it is, that means we should be able to find it just by guess and check, right? It's not going to be some weird decimal, especially not in the non-calculator section. So all we do is we just test some numbers around 0, and eventually we'll come to it. So is 0 going to make this a true statement?
No.
No. Okay. How about 1?
Yes.
Okay. So if 1 doesn't work, then you try -1. If it doesn't work, then try 2. So after you try a couple of numbers, you're going to get it. So 1 does work. If I plug 1 in for x, 1 plus 1 is 2. 2 minus 2 is 0. So we're good. Now, if it was a calculator question, then you may have to enter this in the calculator and then have to find that decimal value. But typically, I don't see that too often. Okay, so here, guess and check, we found x equals 1. So we know that is important because now we can work towards the function's derivative and have a value to enter in. So if we find f prime of x, then we can find f prime of 1. If we can find f prime of 1, then we can work our way to the slope of the inverse. So let's find f prime. We just go through power rule. We have a number, we have a value to insert in for f prime. One to the fourth is 1. 1 times 5 is 5. 5 plus 1 is 6. So if f prime of 1 is 6, then the derivative of f inverse at 2 must be what? 1/6. Yep, always that relationship. Don't change the sign, just flip the numbers. All right, any questions? All right, so I encourage you guys to go through the rest of this worksheet, understand that these are the topics I'm going to be focusing on. I try to put one of each on this worksheet, but some of them I either didn't have room or has some variations of it. So make sure you go back and look through the other multiple choice worksheets that focuses on these fall topics, and you should be ready for tomorrow. But I will have a help session this afternoon to go over the rest of this worksheet in case you need some more support. Feel free to send me a remind message if you have a question that if you have a specific question that you want me to answer. All right, thanks everyone. Study for your test. I'll see you guys tomorrow. I'll send out a reminder. Make sure you check your bell schedule. The bell schedule is kind of changing every day. So, but tomorrow and Wednesday will be the same bell schedule. But just make sure you know when class starts. Oh, and then for fourth period, you guys have a little bit longer period, so I'm gonna release the test when the bell rings. Okay, so right when the bell rings. All right, thanks everyone. See you guys tomorrow.